Now let's talk about availability. Now let us say we have a finite system that undergoes a change of state. This means that you can say there is some useful work that is being obtained during a process. Now this process is basically a finite system undergoing a change of state. Okay, now when this is happening, that is, some work is being obtained during a process from a finite system, the process must terminate when the pressure and temperature of the system become equal to the pressure and temperature of the surrounding. That is, when the system reaches the dead state. Let's take an example and understand this. Okay, so let us say, so before I do that, let us define, or let us put the words into a statement. That is, a finite system undergoes a change of state. That is, a process takes place. Okay, now during the process there is some work output. Alright, now this work output, it becomes 0 at P0 and T0. That is, when the system reaches the dead state. As simple as that. Now if you look at this particular figure over here, let us describe this statement in the shape of a diagram. So we have an air engine. So let us say this is my air engine, okay, which is driven with the help of a compressed air cylinder. Okay, so what is happening? This air engine, this can operate with compressed air from a cylinder, and it will continue to deliver work output till the pressure of air in the cylinder becomes equal to that of the surroundings. That is, it will keep on giving us work output. Let's not make it PMM2, let's have some heat rejection as well. So it will keep on giving us the work output till the pressure of the compressed air becomes P0. There is no pressure difference between the system and the surroundings. Okay, so this is the case of, or this is an example of pressure equilibrium at the dead state. There is one more thing, that is the thermal equilibrium. So you can take the example of exhaust gases. Okay, so you have some exhaust gases. So let us say this is the engine. Okay, so this is the engine. So this is the inlet and this is the exhaust. So the exhaust gases, they go and run a turbine basically. Okay, so they run a turbine. So this is a turbine, and this is coupled to a compressor, and then you have the exhaust from the turbine. So this is the compressor. So when the exhaust gases, which are hot, so these are hot exhaust gases, they enter the turbine. Okay, so during this process, the gases, they perform some work, or they deliver some work via this turbine. That is, it rotates this shaft which is coupled to the compressor, and the compressor rotates as well. So this can only be possible till the temperature of the gases, that is the exhaust gases, become equal to T0. So when the gases reach the temperature T0, that is the temperature of the surroundings, the work delivered by the turbine will stop. So this is an example of the thermal equilibrium in dead state. So this now forces us to, or compels us to, define availability. Okay, so this is basically an example to illustrate that how the system, or you can say any spontaneous process, would terminate at the dead state. Okay, so now let's define what availability is. So you must have understood, and you must remember the concept of useful work. Okay, so let us now define this, that is availability, and it is represented by a letter capital A. Now availability of a given system is defined as the maximum useful work, the maximum useful work. Okay, so maximum useful work is basically total work minus the work done on the atmosphere, that is P naught dV. Okay, so this is basically the definition of availability. So this means that availability is nothing but the maximum useful work. So it is a composite property depending on the state of both the system and the surroundings. Okay, so if you talk about any other property like pressure, so this pressure is of the system. If you talk about energy, this energy is of the system or of the surrounding. So this is defined for a system or for a surrounding, but availability is defined for both. It is a combination, or you can say a combined property for the state of both the system and surroundings. Okay, so I hope you understood the concept of availability and how all these spontaneous processes must terminate at the dead state. Now, in the next video, let's look at the analysis of availability in a steady flow process and in a non-flow process.